Hey Chemistry, Mrs. KJ here, going over 1.19, Graphing. Graphs show relationships in chemistry. In this lesson, you will learn how to make graphs from data and describe what useful information can be found in graphs. Goals for the lesson: understand the importance of graphs in the study of chemistry, create graphs that clearly and accurately display data. So graphs show relationships, graphs organize data, and therefore it shows the relationship between different data that you collect. Graphs plot the independent variable on the x-axis or across. Graphs plot dependent variable on the y-axis. Now, I always think of x across and y as in shrug your shoulders. Why? I don't know. Why? Look at your shoulders. They're going up and down. So it might seem silly, but if you're always getting those backwards, that might be a way to help you out with those. And you can download the study guide. Graphs show relationships between variables. Consider a balloon filled with helium. What do you think will happen if you warm the balloon? If you guess the balloon expands, then you are correct. Conversely, if you cool the balloon, it should contract or get smaller. In other words, the volume changes as you change the temperature of the gas inside the balloon. So if you ever bought helium balloons in winter, you will see that. When it's in the store, it's nice and puffed out. You go into the car where it's so cold and the balloon looks half deflated. Once you get back in your house, the balloon is all nice again. But how can you express this relationship in a clear and meaningful way? Perhaps you would draw a picture. That's what a graph is, a picture showing relationships. So in other words, the relationship meaning when one goes up, does the other one also go up, or does the other one go down? When you plot the volume of a gas against the temperature, the line of the graph shows the relationship between the two variables, temperature and volume. Temperature is on the x-axis, and volume is on the y-axis. As the temperature increases, so does the volume. As the temperature decreases, so does the volume. Because the relationship between the two variables can be described by a straight line, this graph is a linear graph or shows a linear relationship. And we would specifically say that as temperature increases, volume increases through a linear relationship. So for example, if I said, okay, oh, they don't give me numbers over here. So I guess we won't do an example yet. We'll come back to that. All right, let's add a little bit to our notes. And I just kept the introduction and the goals. Our keywords and pronunciation: dependent variable. In an experiment, the variable that the experimenter observes as a result of changing the independent variable. And is this one on the y or the x-axis? And the dependent is on the y-axis. And independent, in an experiment, the variable that the experimenter changes. And this one is going to be on the x-axis. And slope. We'll come back to slope. All right. So let's add on here a linear relationship. So I added linear relationship when the relationship between the two variables can be described by a straight line. So if temperature increases, so does volume. This would be a positively sloped line. Okay, so what would that line look like? We would say that it looks like that. What about if the temperature increases and the volume decreases? This would be a negatively sloped line. It's still linear, but how would the line look now? Now it would look like that. A graph has different parts, and all graphs should have these features. The x-axis. This is the horizontal axis, or going across, where the independent variable goes. The independent variable is the one that the science manipulates. It's the one that I do. Independent, I do that one. Note that time is usually an independent variable. Y-axis is the vertical axis, up and down, where the dependent variable goes. The dependent variable changes or depends on the independent variable. So it's the response. Axis labels, both axes are labeled to indicate that what they represent and what units are used. Scales, both axes have scales, evenly spaced increments that cover the range of numbers of the variable. Increments are shown by tick marks on each axis. So let's look at what they mean by that. And so my scale here goes line 10, line 20. So what would my scale be? My scale would be 5. Every tick mark, every line is 5. 5, 10, 15, 20. Now, the X and Y axis can have different scales, and a lot of times they do. This one goes 0, line 0.5, line 1. So how far apart is each tick mark? It is 0.25. Now you might have been able to figure that one out, but if you're like, oh man, how do you do that? There's a very easy way to do that. What you do is you say, okay, I went from 0 to 0.5. So you put in 0.5, and then you say, how many lines was that? 1, 2 lines. So that you take that 0.5 and you divide it by 2, and that tells you that each one is 0.5. So we could do the same thing down here too. We could have said the first number they give me is 10. It took 2 tick marks to get there. 10 divided by 2 is 5. Data points. The x, y coordinates of each data point are plotted. So remember when you are doing that, for example, this point right here would be approximately 17, 0.9. And then remember you'd have it in parentheses. And the trend line. A trend line is drawn to show the relationship. It can be straight or curved. Note that the line does not connect the points. That's really important. We're going to be doing trend lines, and those of you that took physical science know how much we do trend lines. It does not connect the dots. Instead, it's a straight line to show the average. Notice how one dot hits it, and that doesn't always happen, but in this case, 1 hit it, and I have 2 below it and 3 above it, so that's pretty balanced. It's got to be balanced. I could not draw it down here because then all my dots would be above it. So it's like you're trying to get through as many as possible and balance it on the top and the bottom. So that is our trend line. Data points, scales, x-axis or independent variable, the one that I do, the y-axis, up and down, or the dependent. So whatever this is depends on this. So what my pressure is depends on how hot it is. Depends on the temperature. And let's add in to our notes, dependent variable. Again, we said it was on the y-axis. Example, if you measured your mass after every pie you ate, the blank would depend on blank. So blank is your dependent variable. All right, so if you measured your mass after every pie you ate, the mass would depend on how many pies you ate. So what is your dependent variable? The mass or the pies? It is mass. Let's look at independent. Example, if you measured your height every year, blank would be the independent variable. Then it would be the time in years. And as they said, time is almost always the independent variable because your height depends on what year it is. So the year is independent, the height depends, so the height would be your dependent variable. Follow these steps to graph mass and volume. Let's say that you had a liquid substance. You place an empty graduated cylinder on a scale and record its mass. Next, you pour 10 milliliters of the substance into the cylinder and note the mass of the cylinder plus the liquid. You add another 10 milliliters and do the same. You repeat this procedure until there is 50 milliliters of the substance in the cylinder. You then arrange your data in a table. So the cylinder by itself is 90 grams. After I add 10 milliliters, it is 116 grams. When I went all the way up to 40 milliliters, how much was the mass? 185. So this is the data that we got. Now we're going to set up the graph. You're going to draw 2 axes. All right, well, which one do you think you're going to have for your dependent and independent variable? Let's do the independent variable. That would be your X or your Y. Independent is the X going across. And we have the volume and we have the mass. So would we say that the mass depends on how much volume we put in, or the volume depends on the mass? Well, which one did I do? I added the volume. So since I added the volume, that's your independent, and the mass depends on how much liquid I added. So thinking it through in those sentences can be helpful. All right, so we labeled our x-axis volume in milliliters. Volume is the variable that you changed, so the independent variable that I changed. Label the y-axis mass in grams. Mass is what you measured and is dependent on the volume of liquid added. So it's the dependent variable. So how much the mass was depended on how much liquid you added. Choose the scale for the x-axis. All right, so if we look back here, our volume goes from 0 to 50. So they said, all right, let's just go 0, 10, 20, 30, 40, 50. Since we added it in 10 milliliter increments, that makes sense. However, let's go over here and say, okay, our data goes from 90 to 195. So they did 90 and they went up by how much? They went up by 20s. And you have to go above your highest data point. So our highest data point was 195, and you had to go up here. Okay, I'm going to pause and talk about this for a second. If you turn this graph into me, I would mark it wrong and tell you to fix it. Do you know what's wrong with this scale? Well, according to the rules of math, what point has to be at your axis? It has to be 0, 0. So I would have to start at 0. And then my next line would be 20. And my next line would be 40, and I'd have to keep going. Now, the reason they started it here is so that the graph was bigger and you could really see the relationship. However, the issue is it is illegal according to the rules of math. However, there is something you can do to make it legal. And you may or may not have learned this in your math class. So what you do is you draw basically what looks like a curvy M, and there has to be 2 of them. Well, there used to have to be 2. There might not have to be 2 anymore, but you draw these little lines. And when you draw those little lines there, it's like you said, hey, my graph should really go way down to here, but we don't need this part. So we took a scissors, we cut it off, and we glued it together up here. So this line shows that you cut it and glued it, and that's why you're starting there instead of at the point 0, 0. So those 2 little M's make it legal. All right, so I said choose the scale for your y-axis. Mass ranges from 100 grams to 195 grams. So make sure the axis goes from 90 to 210 to include the 195. This allows you to see above and below what is measured. Plot each data point for mass versus volume on the graph. Label the graph mass versus volume of liquid substance. All right, so we are going to plot our data points. And you can see that they added some grid or help lines, but I'm going to turn those off for now. So let's look at our first one. Our first point is at 0 for volume, 90 for the mass. All right, so 0 for volume and 90 for the mass. Our next point is at 10 and 16. Remember, if these, oh, it's not going to let me. If these were written like how you write them on your paper, you'd put parentheses, 10, comma, 116, parentheses. All right, so we're at a volume of 10 and a mass of 116. So 10, here's 110, here's 130. Okay, we need to know how much each line is. All right, so we went from 90 to 110. How far apart is that? That's 20 apart. Might be easier to see here too. If I go from 130 to 150, you can see that they are 20 apart. And how many tick lines? 1, 2, 3, 4. So we use our little trick and we say that We had 20